Video surely help for your competitive exams like JEE and NEET. Now we are discussing some PYQs of coordination complexes. So the number of geometrical isomers found for the metal complex has given like this. So now we are going to find the geometrical isomers for this. So first we have to know what kind of complex is given in the question. So first complex is Ma2B2 type, like two ligands, those are different with metal. And second one is Ma4 type, third one is Ma3B3 type, and fourth one is Ma2B4 type. So the first complex Ma2B2, so especially platinum coordination number 4 complexes are square planar in nature, so that all square planar can have cis trans isomerism if the different ligands are like this. So if same ligands are opposite to each other, trans is side by side means cis. Coming to Ma4 type, so Ma4 doesn't have any geometrical isomers because there is a trick for this. If in any case more than one way can't able to write means those doesn't have geometrical isomers. The same way first case you can see that way, that trick. So AB ligands means this is one way to write it, and AA is the another way to write it. Since we can write two times, so one is cis, another one is trans, but that is not possible in case of Ma4, so that doesn't have geometrical isomers. So Ma3B3 type, so this will show facial and meridional isomerism. Based on the location of ligands, we can decide if all three are in same plane, one isomer, suppose AAA like this, and other cases like this, BBB. So this is one isomer. If you change any one of them, that will be other isomer. Coming to Ma4B2 type, so Ma4B2 also can show geometrical isomers. So because here also cis trans isomers are possible. So how can we write that? If same A ligands opposite to each other, so it will be like this. If same ligands, write it. So AA ligands if it is opposite, because En is neutral bidentate ligand, symmetrical ligand, so it will be like this. In another case, A and A, write it side by side. That's how we can find cis trans isomerism in this complex. So what we can conclude, first one have cis and trans, so 2. Second one doesn't have, so 0. And third one and fourth one also have 2, 2. So answer is third option. That's how we can get the answer. Coming to the next question. So the next question is homoleptic octahedral complex metal ion of M plus 3 with these moderate ligands, monodentate ligands. So the observed wavelength in the respective colors, the increasing order of the ligand strength. So here what we have to know is this is a homoleptic complex with M plus 3 ion, M plus 3, and then so ligand 1 given green color, ligand 2 is blue, and ligand 3 is red color. So we know that energy equals to Hc by lambda. So shorter the wavelength, higher the energy, and stronger the ligand. So what we can simple definition is, so the ligand which gives high wavelength light considered as lower energy. That means shorter the wavelength, higher the energy, stronger the ligand. So here if you see the Vibgayar colors or Vibgayar colors, so the first is like highest wavelength is red, lowest wavelength is blue, and green will be in between them. So wavelength wise R greater than G greater than blue, but energy wise B greater than G greater than R. So that's how we can get the option 2 is the answer. Hope it is clear. Coming to next question. So the next one is, you can see this, the tetrahedral complex. You can read the question. So the tetrahedral complex, the MnBr 6, the spin only magnetic momentum value, so atomic number is given as 25. So 25 means in this complex Mn will be Mn oxidation, Mn plus 2, it's MnBr4 actually, MnBr4 means Mn plus 2. So what you will get, 4s2, so 4s0, 3d, 5 you will get. So here 5 unpaired electrons are there. Since the ligand is weak field ligand, so the electrons won't pair up, so all the 5 unpaired electrons will be in the unpaired form, because after splitting also T2Z3 EZ2 will get. That's why, so 5 unpaired electrons are present after splitting also. So if 5 unpaired electrons are there, mu equals to under root n into n plus 2 Bohr magnetons. So here n value is 5, so you can get under root 5 into 7, which is 35. So root 35 value you can approximately take it as 5.85 or 5.9. So if there is a short trick for this. So to find mu value, you can directly use this logic. The logic will be like this. So logic is just if n equals to 5, the mu value will be 5.8, or mu equals to n plus 0.8, approximately Bohr magnetron's value. This is the shortcut for finding number of magnetic value. Hope it is clear. Coming to the next question. So current CO, just you can read the second question, students. CO H2O6 3 plus have 3 unpaired electrons. So accordingly, the hybridization of CO H2O6 3 plus we have to use. So the hybridization will be, see, generally coordination number 6 means we can directly see the hybridization either D2sp3 or sp3 D2. Since H2O is weak field ligand, the hybridization is sp3 D2. That's the answer for this, students. Very simple way you can do it. Coming to the next. So the correct increasing order of trans effect for the following. So trans effect mainly depends on the first. We'll see what is that. Trans effect mainly depends on pi acceptor ability, means back bonding, and sigma donor strength. So based on this we can conclude the answer will be, so we know that the ligand strength order from weak to strong will be like this. So NH3 less than Br minus less than C6H5 minus less than Cn minus. So accordingly we can find the answer. So this is the answer. Based on this we can select the option. So coming to next one. Next one, the volume of M. This is a very important model. This is JEE exam question. You can see how to solve question. See the volume they are asking. First we have to find molar mass of the complex. Molar mass will be, you can take CONH36Cl3, so the molecular mass of this will be 267.5 gram per mole, and moles we have to find as second step. Moles of the complex, so they have given 0.3 grams, so 0.3, that is weight of complex, and molecular weight is 267.5 grams. So if you simplify this you will get 0.00 112 mole. And free chloride ions we have to check from the complex, so that is 3. So free Cl minus ions are 3. So the next one is moles of Cl minus. Moles of Cl minus equals to 3 into 0.00 112, which is equals to 0.00336. This is the moles of free Cl minus ions. So we got to know that how many AgCl will be formed, means how many moles of AgCl will be formed, or how many moles of AgNO3 react with this, because AgNO3 mainly reaction happens with respect to the primary valency, means outside how many Cls are there, accordingly AgNO3 react with this and form AgCl. That means moles of AgNO3 equals to the same. This is the moles of AgNO3. So what we can do, volume equals to number of moles by molarity, because molarity equals to number of moles by volume in liters. So accordingly we can do, so 0.00336 by 0.125. So if you do it you will get 0.0269 liters. So we can convert this into ml, which is 26.9 ml. So that's how we can do this question, students. So they are asking volume. First we have to find number of moles. Based on that volume we can calculate. So first one, molar mass we have to find, then number of moles for the given complex, then based on the Cl minus ions outside we can find the moles of Cl minus. So based on that we can find moles of AgNO3 reacted. Accordingly we can find the volume of AgNO3 required for neutralizing this process. That's what the answer. Hope it is clear. So answer is 26.9. So or 27 we can take, nearest to the value. Coming to the next, students, for the complex COCl3 XNH3, same kind of question. So what is the answer, students, here? COCl3 XNH3 with AgNO3. So 2 equivalent of AgCl precipitate out, the value of X is. So how to do this one is, so here cobalt coordination number is 6. So we can use here 2 equivalent of AgCl is coming out, which means 2 Cl minus ions present outside the complex. So here itself we got answer CONH3 5 Cl and Cl2. So how to decide this one? Just carefully observe. Coordination number of CO, that means total secondary valency for cobalt is 6. That means in the box how many ligands are there? 6. How many outside the complex? 2. And to neutralize 6 coordination number, 5 ammonia and 1 Cl ligand is required, so that we are representing in the box. That's how the answer will be what, students, here? So x value equals to 5. Hope it is clear. Coming to the same, the conductivity of solution complex with formula COCl3NH3 for corresponding 1:1 electrolyte. So this is also same like that. So 1:1 electrolyte, how to understand? That means the complex after splitting, one positive and one negative ion is forming. That's what the summary of this question. Now how to decide this one is, just the complex is CONH3 4 Cl2 and outside also Cl. So here if you break this, this whole complex is plus and this is minus. So number of primary valency. So they are asking primary valency. So the primary valency will be 3, right? Because Cl, inside Cl and outside Cl both are responsible for the finding oxidation state of central atom, students. So here one point you should understand, whether the negative ions are Cls inside or outside, it doesn't matter, all comes under primary valency. That is point number 1. Coming to secondary valency, whichever ligands inside, those all comes under the secondary valency of the complex. So our simple way, how many are inside the box decide shape or geometry of the complex or coordination number of the complex. And how many are responsible for deciding oxidation state of central atom comes under primary valency. So here NH3 is neutral ligand, Cl is -1 ligand. Accordingly we can tell CO have +3 oxidation state or primary valency is 3. That's what the answer. Hope it is clear. Coming to this question, students. So the complex X of composition CrH2OCl6, just you can see the question. H2O6Cl2 has spin only magnetic momentum 3.83. It reacts with AgNO3 and it shows geometrical isomerism. The IUPAC name of the complex is. So here the conditions many have given in this. So they are saying magnetic value is 3.8. So what we can understand from this? So N value supposed to be 3, students. How to understand? Because I already given clue, mu equals to N plus 0.8 approximately, correct. To get 3.8 or 3.8, nearly N value is supposed to be 3. So when we are going to get 3 unpaired electrons, so when we take Cr plus 3, so atomic number is 24. If you remove 3 electrons, you will get, the actual configuration is 4s1 3d5. So we have 6 electrons. So here 4s0 3d 3 will get, because from this first we need to remove electron from 4s and we are going to remove electron from 3d. Accordingly you can get 3d3 is the configuration. So how many unpaired electrons are there? 3 unpaired electrons we are going to get. After splitting also we get 3 unpaired electrons only, because K2Z will be at ground level. So 3 unpaired electrons, so it is matching to this condition. So Cr oxidation state is +3. And coming to, it reacts with AgNO3 also and shows geometrical isomerism. So this complex is having total 6 ligands, means coordination number is 6. So in this case, so here Cr H2O 5 Cl. So actually this complex is Cl3, it's not Cl2, it's Cl3. So we can get here Cl2 and 2H2O outside. So here, Cl2, just a minute. So M H2O 4 Cl2 and Cl with 2H2O. This is the complex. Why? Because the form which shows geometrical isomerism is Ma4B2. This will show geometrical isomerism. So we already discussed how it will be. So if the BB ligands opposite means trans, side by side means cis. So that's how we can conclude. And it also react with AgNO3 and make 1 mole of AgCl. So accordingly the answer for this is tetra aqua dichlorido platinum 3 chloride. So answer is first option only correct. Tetra aqua dichlorido chromium 3 chloride. So that's the answer for this, students. Here wrong answer is given. Hope it is clear. So just 3 cases we discussed. First, magnetic value based on the number of unpaired electrons and oxidation state. Second is whether it makes AgCl or not. That means outside Cl is present. Third case, which form of this complex have geometrical isomerism. So answer is this option. So the one that will show optical activity is, so optical activity, yeah, the options are not given properly. So optical activity, where it is possible, I will tell you in simple way. If no symmetry is present, the symmetry is any of type like POS, COS or axis of AOS. the complex doesn't have symmetry, any of these, like all these symmetries, then only the complex is having optical activity. We can also check the same point with respect to mirror image. If the complex is having mirror image, then also there is no option to see the optical activity. So non-superimposable mirror images are called enantiomers. Wherever you see that kind of compound or that kind of representation, that alone having optical activity. If you want to know more about this, just letter A if you keep in front of mirror, how it looks like, it will be same. That means this can superimpose over this. So that's why it is not optically active compound. Means A is not optically active. Suppose if you put Q, so it will be as like if you put P, it will be like Q over the mirror. So exactly cannot superimpose over this. That's why letter P or Q shows optical activity, or this kind of complexes are optically active, and A such kind of complexes are optically inactive. If you want more about this, you just comment me, I will explain that. And coming to this, the number of geometrical isomers found for this, we already did this question there also. So PT, the same question we did here. And coming to the total number of isomers for square planar complex. So for square planar complex, MF, AB, M, AB, CD, if you take, it's NO2, not NO twice. So in this case, total square planar, total number of isomers, how many you can see here. Just this is square planar complex. You just keep one ligand constant and change other ligands. So first time I take 3 Cl. With respect to fluorine, how many times I can write different, like with respect to fluorine, how many times I can change the ligands, which is opposite to fluorine. One is with Cl, one is with SCN, another one is with NO2. So we get 3 times, like 3 different ways we can represent by keeping one constant. So like that, total how many possibilities? So 4 ligands are there, 4 3s are 12. So answer is what? 12 geometrical isomers are possible. 12 isomers are possible for square planar complex. So thank you. And coming to the next, the total number of moles of AgCl precipitated with excess AgNO3. So here just simple way, Cl, one Cl outside, so that one AgCl formation will be, and here 2 Cls are outside, so 2 moles of AgCl. Here is no Cl outside, so there will be no AgCl formation. Here is 2. So total how many you will get? 5. So 1, 2, 3. So 5 AgCls are possible. So here you can understand, if the ionization sphere have Cl, then only AgCl formation happens when it reacts with AgNO3. So that's how the reaction of COH2O6 with excess ammonia, prions of oxygen, diamagnetic complex, number of T2G electrons. So that's the question. So here, so diamagnetic complexes, how can we get it? So COH2O6